Thank you, everybody, for joining us today. Yeah, I'm Paul Goosens. So I'm heading up the Systems Engineering Solutions group at MapleSoft, and I'm joined by Barani Mohan, who will be actually doing most of the heavy lifting on in terms of demonstrations and getting into the details of it. So I'm going to start with just giving a sort of high-level introduction on MapleMBSE, and then we'll get into the meat of certainly the collaboration aspects of it. But we also want to talk a bit more about some of the applications that can be used, that MapleMBSE can be used for. We've in the last 2 years we've been involved in selling and marketing MapleMBSE. There are some pretty fundamental questions that people are asking us, and we'd like to try and address those in this session. So let me start by just talking about just some of the challenges that certainly we're seeing among our customers and beyond. Obviously, within the systems engineering field altogether, there are some major challenges in terms of getting the process adopted, as well as the technologies and the tools for implementing in very large, complex projects. And I want to just sort of put this slide up from SimData, who have done quite a bit of investigation into this market. And certainly what we're seeing is that there is a lot of hurdles that need to be overcome just in being able to deal with the culture, company culture, education and training, organization, and so forth. So this is really about the people rather than the tools and processes, and how we can overcome some of the reluctance that is very often encountered when trying to implement a systems engineering process. So from our own perspective, what we've seen is that the typical process would be something along the lines of systems engineer is developing the architectural model as the authoritative or single source of truth, and using their skills to implement that model, typically in a SysML environment, typically using tools like Magic Draw or Cameo or Rhapsody in order to implement that architecture. And then we have all the various other stakeholders, everybody who's involved in the project that needs to access information, do something with that information that can then help them make certain decisions in each stage of the process, and that information that is generated from those tasks then have to be transmitted back to the systems engineer for them to be able to take that information and turn that into or add that to the systems model. And this tends to be a very ad hoc process. It'll be a combination of presentations, spreadsheets, documents, and so forth that are submitted to the systems engineer. But this is where the friction starts to arise. This is a very human interaction, and very often there are misinterpretations or miscommunications. We start to see errors introduced into the systems model. And of course, when those errors are come to light, then there's endless design reviews trying to understand where the problem is and try to fix it, which just creates a huge amount of churn and friction between the systems group and the other players, the other stakeholders in that process. So what we are proposing is, well, why not give all the project stakeholders direct access to the systems model, and not only for being able to access the information from the model, but also to submit those changes back into the systems model in an appropriate way, in a way that they understand and they feel is appropriate and consistent into the systems model. But in order to do that, we can't expect these people to be using tools like Magic Draw, Cameo, and the traditional systems models for doing this, everybody will resist using those tools. And let's face it, nobody really wants to know or understand what SysML actually is. All they want to do is do their job and be able to get the information in an appropriate way back into the systems model. So our proposal is, well, why not give them a tool that everybody knows and understands and has access to, which is Microsoft Excel. And by doing that, now we have a way of being able to make the information available across all those folks involved in the project. The design reviews become much smoother. All the information that the other stakeholders have put into the systems model becomes much more accessible. And now the systems engineer can use this to perform much more effective design reviews and accept the changes or reject them, but certainly be able to review and then submit those to the final systems model. So that's one great way of being able to, for all the stakeholders to be able to collaborate with the systems engineer. But it goes much further beyond that. Now all the stakeholders can actually collaborate with each other. So anything where groups of people need to be able to work together to generate the information that goes into the systems design can actually do all their work again through the systems model and just using Excel to do this. And that's what MapleMBSE does. So what we are providing with MapleMBSE is effectively an interface between the Excel user interface and the systems model. So as far as the end user is concerned, all they see is a tabular view of the information from the model, but served in a way that is specific to the task that they're working on. And then under the hood, we're providing a synchronized bidirectional connection between the two environments. So any changes that are made in the system model in Excel are instantly submitted into the systems model, and conversely, any changes that are made in the systems model are pushed back to the user interface in Excel, through a synchronization. So one of the things I want to make clear here is that this is not file input output or file export. We're not generating XLS files in order to serve up these views. It's a very tight integration with the system model. And in order to create those task-specific views, we provide tools and a back end to be able to create the customizations. And we currently are integrated with Rhapsody and Magic Draw through Teamwork Cloud. We have some plans to support other platforms. So if you're using other platforms, please let us know. We're trying to figure out what would be the next set of adapters we should be creating. So at the end of the day, we can actually provide a tool or a means in which everybody who is involved in the process can actually engage through the systems model. And this reduces the sort of kind of friction that we see. It helps to increase confidence and buy-in into the process by working this way. People using this tool typically need maybe 2 or 3 hour briefing on how to use the tool, and then it's very quick to start using that. And then we have several case studies that actually show that by using tools like using MapleMBSE in this kind of way, we can dramatically reduce the kinds of errors and, of course, the inherent costs that are involved in doing that. And then on the back end, this MapleMBSE is not a black box. It's very much open. So we actually have open APIs that can be used to integrate into other tools or other data sources within your tool chain. So this is something that's going to be very useful for with the IT services and so forth. So that's the high level the description of what MapleSim is, MapleMBSE is about, and certainly the motivation for us to be developing this tool, and certainly we're seeing a lot of interest in acquiring it and uptake. But we do get a few questions that are frequently asked, and certainly the first one, as far as collaboration is concerned, is that isn't this a recipe for mayhem? Are we creating some kind of free-for-all by allowing all stakeholders to be able to make changes to the systems model? We contend that no. I mean, there are the MapleMBSE has to be used in the context of a structured process in which the systems engineer is the final arbiter of what changes are actually submitted into the final model. We're just providing a way of getting the information into the system model in a more consistent and a more coherent way, and we'll certainly talk more about that in the next section. The applications, so we do get a lot of questions about what kind of use cases should MapleMBSE being used for, and we'll talk more about that in the next section. And then the final one is evaluation. How do we get started on this? And again, I will wrap up in this session and talk about some of the new programs we've got in place to help make this a very smooth and successful process. So as far as collaboration is concerned, I'm going to pass this over to Bharani, who's going to talk about some of the tools that are built into the MapleMBSE in order to be able to address some of these concerns about the control of the information and making sure that one group of people don't stomp over the changes that are made by other people and so forth. So with that, I'll pass this over to Bharani.
So for model scope definition, what we mean here by model scope is the system engineer has complete control of which part of the model that has to be exposed to the subject matter experts. So subject matter experts here, they are the experts in their own field, but they are not familiar with SysML or the modeling tools. So they are the actual focus for using MapleMBSE. And system engineer can control the tasks, the different views that has to be given to these users, and he can determine where any of their information that is being input into the model will go on to the model. Something like a holding bin. If there is a temporary holding bin, any changes or any elements that is being added by the end user, who is the subject matter experts, will always go into that holding bin. Then system engineer can review it, and then it could be added to the part of the model. So system engineer here has complete control. You also using the permissions from the Teamwork Cloud server, you can assign a user to be a reviewer. So in this case, the reviewer will be able to only view the model information, but he cannot edit or change and save it back to the server. And also you can restrict the number of projects that's available to a user. So if a user is given a permission to access just few models, he can only select those few and work on it. So on the end, the system engineer has the complete control over what kind of views, which part of the model, and what information has to be edited by the subject matter experts. So also to facilitate different users collaborating and accessing the model at the same time, we support locking, same as how CSM or Magic Draw supports. Once you start editing a model in MapleMBSE, you will acquire locks for those elements, and these changes will be made on the Excel front end. In case MapleMBSE is not able to access the model because it's being locked by a different user who is using Cameo or MapleMBSE session, the user will be notified saying we are not able to acquire the logs. So in this case, you will not be able to delete, edit, or make any changes to this part of the model. But you will still be able to add elements that are not being logged by the different users. And once you start editing it, the users on Magic Draw or Cameo will be able to see specifically next to each of the model element your username that this element is being logged by a different user. And once you save these changes back to the server, or when you reload the model or close a MapleMBSE session, all these logs are automatically released. And we also have support for branching. You can access different revision. Get your merging here is just to retain your changes and go to the new branch if there is a commit from a different user while accessing the same project. So to create a new branch during commit, you'll see a commit dialog box as shown on the right here with the option to add a new branch. So you can create a new branch with the description of the branch and name, and you can create a new branch from the trunk or from whichever revision that you selected. And you also have the option to select an arbitrary revision. So in Cameo Systems Modeler or in Magic Draw, to view an arbitrary revision, you need to create a branch to that revision, and then only you will be able to view the information. But in MapleMBSE, you can just access that revision without creating a branch. If you decide to create actually a branch from that specific revision, you can add a branch, and this will be saved to the server.
So if there are any questions on the collaboration side of things, please type them into the Q&A, and while we're getting ready, Brian's getting ready for the next part of this session, we're actually going to be doing some live demonstrations, but we can maybe answer a couple of questions before we get into that. Otherwise, we're trying to leave enough time at the end of the session to cover any questions on this. We know this is a very important and critical factor in deciding to use a tool like ours, and we put a lot of effort into making sure that there is no mayhem, that it does actually support the collaboration in an appropriate way. Okay, so the next thing we want to talk about is, well, what is MapleMBSE good for? I mean, we get a lot of questions about, what would make an appropriate use case for using MapleMBSE, and there are many, many different tasks that where we can see some good use for this. What we're going to do in this next section is I'm just going to talk in general terms about what would be an ideal use case. And then we'll pass this over to Barani, who will go through some specific examples with some live demonstrations. So typical things we find are things like importing lists of components, failure mode analysis, interface connection, documentation, and then traceability. But I'll leave that to Barani, and let's just talk a little bit about the high level. What does make the ideal use case? Where would you start with doing this? And I think this really it comes down to your own specific circumstances and the kinds of challenges, or where the challenges lie within your own processes. So at kind of a high level, I mean, certainly the first kind of task that we typically see is where there is a requirement for large quantities of information to be integrated into the systems model. Very often the systems engineer can only put the architecture to a certain level of granularity before requiring a subject matter expert to come in and to actually start populating with more detail into the architectural model. That kind of information can easily be captured within MapleMBSE and then integrated into the systems model. Tasks that require specialist skills, you need the information from on the knowledge of the SMEs in order to create the information that's needed to go into the systems model. And again, these are typically things that are done very ad hoc in reports or spreadsheets that are passed to the systems engineer. Now, we can provide a tool where the SME can just simply put that information directly into the systems model and then review it with the systems engineer. Certainly, I'm sure if you looked around at the kind of activities that are involved in your own projects, you're going to find a lot of people are using spreadsheets for doing this kinds of work. The work that could really be very easily integrated into the systems model. So anything that we're already using spreadsheets to perform certain tasks would be a very good candidate for if you're actually getting started in implementing MapleMBSE. And then this final one isn't. Brian's going to talk about this in this final example. But there's actually a lot of analysis of the systems model that needs to be done. Things like dependencies or interdependencies. What effect does certain changes make to the structure of the, or even changes to the parameters can actually have significant changes or effects on the rest of the of the design. So typical things would be things like the design structure matrix, sort of identifying the interdependencies, traceability analysis, which we'll be talking about in more detail here. So these kinds of, they're more sort of report generating tools, but certainly can be very powerful applications using MapleMBSE because of that tight integration into the systems model. So with that, I will pass it over to Barani to go through some examples. And again, if you have any questions as we're going along, I'll be monitoring the Q&A, and we can address some of these questions as we're going along, or we can leave it to the end.
Okay, I'll go ahead and launch MapleMBSE file. So for the first example, what I'm going to do is I'm going to import must equipment list. So I'll give the details of it once I have access to the server information. So before that, let me show the import file. So this is an import file. It's from the Lunar Relay satellite. It's a report that's publicly available from NASA. So I just took out a table with different list of components, their mass, calculating the total mass and nominal power. So here you are seeing the login screen for MapleMBSE. In order to connect to the team workload server, you have the server address, username, providing the password to get the appropriate permission. So we will check the permissions roles to identify the projects projects to which the user has access. You have the options to use SSL, use caches. This option is useful when you're working specifically with larger models. And branch is to select different branch that is available for the projects. And this is where you can select the revision number you want to view. And save setting option is used to save all the login information from a previous session, except for the password. For example, let me start with a user called tester. So here, once I logged in, I'll be able to see the projects that have been assigned specifically to that username. So here, our tester has only access to one project. But if I change the username based on the permissions to this user, you will be able to see the different projects that are available to be selected from. So here you can see a list of different projects that's available for this specific username. So once I log in, based on the configuration file that I just clicked on, I'll be able to get the information. So here, just to give you an overview of how MapleMBSE works. So we have the SysML model, or the system model, being stored in a model repository. So in our case, it's the team workload server. And what MapleMBSE will do is, based on the configuration file. So this is the file that I clicked before this session. So this file will have information of what kind of model elements that I want to get from the model, where they are located in the model, and how do I want to display these elements onto Excel sheets, and what informations of those model elements that I need. So here, as you can see, we can define a scope. So I'm not going to expose the whole model to the user. I am going to have just limited exposure. What MapleMBSE will do is it will transform these SysML model elements into a logical table. So it will transform these informations into a table, and this table is projected onto an Excel front end. So that's why you have this interconnection. Every time you make changes to Excel cells, you are actually interacting with the model on the background. But all these changes that you make, it's completely local to the user unless you commit the changes to the server. And so, like I told you, for the for the master equipment list import, I'm going to just import all the components, define certain hierarchy, I want this part to own list of these components. And then I'm going to commit the changes to the server. We are going to see how these imported elements are being changed as SysML elements. and then make some changes again in Magic Draw or Cameo, and then we are going to see how those changes will again be reflected back into MapleMBSE. So here you can see the components table. So it's completely empty here, and I can let me open the model in Magic Draw. So I'm going to import all these components into specifically to LRS package. And another thing that I want to mention here is you will be able to also see on the top of the title bar, you will see the server that you are connected to, the project that's being accessed, the user, and the revision that we are accessing currently. So let me go ahead and just import the file. So now I'm just importing all the information. So every time during import, I'm going to be creating each of those components based on the stereotypes and also the different value properties that have been assigned to it. So currently we can import around. So as a test, we were testing to import around 10,000 elements. So with our previous release, we can do that easily about in less than 20 minutes. But with our current release, we have updated the performance. You can do that in just 4 minutes. So once the import is done, you will see the number of records that has been imported and how they are being updated. So here I have imported all the components. And in the next sheet, this is where I have specifically created this view to create hierarchy between the components. And here you can see that, for example, the KDT transponder, I want the number of quantity to be 2. I have unit mass for each unit, then the current best estimate for the mass, a percentage growth, and the total mass for that component. And here I wanted to create a hierarchy saying that, so KA band for 40 by 37. So I want to assign certain components to it. So here I'm having the KA band and I want to add these components as. So what I'm basically creating is a part relation between K 4037 DT link and these other components. So same way I'm going to create some more hierarchy. So this time I'm going with the KA band 23 bar 26. I want to assign these 3 components. I'm just using Excel's copy paste and dragging just to create the same to fill the series. And then I'm going to assign 2 components to KA band 4037. So now I want to add some components to SA band relay link. Another component to data router. And I'm going to assign the rest of the components to antenna. So there, here I'm just assigning these components to be part of a top level component here. And say I want to assign each of these components that I again created to my top level component communication. So all these are list of components for communications. So I'm again creating a hierarchy between communication, KA band, so that. And since now it's already in Excel, you'll be able to use Excel formulas. For example, say specifically for K DT transponder, the number of units I need for the transponder is 2. I say I need to change it to 3. So my estimated mass is going to be a product of these two values. And then this is again going to change my growth percentage result based on these values. And my total mass is going to be sum of these values. So that. And I need to also update my K-band 4037 for which is also within communications. So here I am just say I want to calculate something like the complete unit mass for all the components that is being added to the K band. So now I can also add kind of descriptions to it to say as a notification or just as a description for each of these components. Now I want to save these changes back to the server and see how these elements are being reflected in CAM. So once what I did is I double click on the save button. So once I do this, commit to Teamwork Cloud dialog box is going to appear. So I'm just providing a message to saying that I'm adding you a mail list. So in case I need to create a branch, I can enable create a branch option and add a branch name. So now I'm just going to commit to the trunk. So on clicking OK, my changes have been submitted to the server. You still don't see these changes because here once you commit, our server revision will be changed. So it has been updated to 705, but we are still in the older revision. So to get the latest changes from the server, I'm going to update my model in Cameo. So there you see the list of components that we have added. Let me lock these elements so I can see this as blocks. So here you can see all the components that we created. We have created the component. There have been, by default, I have added stereotype as block components. And for each of these, the value properties, you can see that we have created the value properties with units and default values in all the cases. For example, for power, I have added the unit to be watt and the default value. So you can see that I have missed to add hierarchy between two components. So here I did that. So I wanted to show the changes that will propagate between Magic Draw onto Teamwork Cloud. So I'll go ahead and lock all the elements here and create a composition relation between communication and data route SSR. So if I go back to my model here, you can see that communication, I have not added specifically the data router to be part of communication. So I'll go ahead here and commit my changes. So on committing, I'll need to update my model here. So here you can see that now data router is also being added to part of the communication. And so that completes the MBL import. Now I want to go ahead with the FMEA workflow. So for FMEA workflow, I have this basically for this example, I have created a very simple table where I'm going to bring in system functions of a conceptual UAV model. I'm going to identify some failure modes for each of those functions. Then these are based on custom stereotypes that I already created in the profile. And I have a table in which I'm going to identify the severity, occurrence, and detectant. So on a scale of 1 to 10, 10 being the highest, I'll also calculate the risk priority number, and I'm going to add a mitigating action as a requirement back to the model. So usually, so in FMEA tables, we are going to have mitigation action, and then we will again calculate the RPN once that has been fulfilled. But here I'm just going to add it as requirement back to the model. So here you see the list of system functions of the model. I'm just exposing only part of the model. So here only the system functions. And here this is a view of system functions on the row and the FMEAs on the column. So for a user, I want to say that I have identified a failure mode for the function drop payload. So I'm creating an FMEA ID. So I'm creating a failure mode with ID 08 and the name has failed to drop payload. So once I create this, I'm just adding these failure modes as separate model elements with a profile FMEA. And now, once these elements are being created, I want to maintain a traceability between the system function. So this is a failure that I have identified for drop payload. So by this relation, I'm creating a dependency relation between the system function and the failure mode. So this is the failure mode table. I can add a description for why this failure or what could be the possible cause for this failure. Something like reason is something like failed to open payload drop door, and this is a very serious problem. So I'm going to give it the severity of 9, and the cause could be something like the hinge support is not working and the occurrence for this is low. So I'm going to give a low priority number for it. And then detecting this. So if I have a built-in startup test, every time when I start the UAV, it's very easy to detect. So that's also not problem. So I'm giving a number 4 here. Criticality is going to be product of my severity and occurrence. Again, using Excel formulas. And my risk priority number is going to be product of all 3. So there. So here I have just created the FMEA table, linked it to a drop payload. Now I want to add a requirement for it. So to do that, this is a view of a table that's linking the requirement that I've created and the failure mode. And this is the same information, but as a tabular view. So I'm going to add new requirement here. So something like payload drop requirement, I'm going to again to maintain the traceability, I'm going to assign this to the FMEA component, and I can provide a description or specification for each of it. So I'm going to skip this part now. I'll just commit these changes to server to see the traceability that we have added. Again, I'm going to update my model. Okay, so here is the requirement that we created, and I'll be able to see the dependency link in the failure mode. So here you can see that I have the activity drop payload. I'm identifying a failure mode as failed to drop the payload. So all the information that we provided in the FMEA table are all again recorded here. So you can see everything, and then as a requirement that's derived from the failure mode. So this is just a simple workflow, but you can completely customize it based on the process that you use. So that's what I had for FMEA. Let me restart to also show the other example for ICD. So for this, I'm going to use an example that's available publicly, and also one small example that we created just to have different views of the ICD. So it's not kind of the documents, but everything that you have in an ICD document, those tables, what kind of information you need. So I'm going to just display all those information as tables here. Okay, so while this is loading, we have a question. If we have any plans of integrating this with Google Sheets. As of now, we are not, we don't have to, we don't have any plans of integrating it with Google Sheet, but we are thinking of doing it with Office 365 to go online. But once we do that, I think, yeah, we will also check in the possibility of integrating it with other environment. I hope that answered your question. And then, so for this example, I'm going to just go fast here. I have the example of a tablet. I'm going to show the different interface which are here as ports, the interface requirements, and then the spacecraft model. So this model is available in the link here. I'm not going to make any changes to the model, but just going to show you the different views of the interface here. So here, interface components, I have a list of the components that's available in the model, specifically of a tablet. What are the different ports? So in this specific column, I'm displaying just the ports and their port kind. So these are all full ports. If these ports are conjugated or not, and same way here in this column, I'm displaying the ports which are of proxy port kind. So they are nothing but just the difference of the stereotype. And here, to each of these ports, if they are tied by interface, so I am showing it here. And then, so if these interface types again has some, say, different properties, I can still be able to create it and show them here. And here you are seeing different interface of the tablet that I have created, description for it. You can kind of add documentations here. And this view specifically for showing different interface requirement that I have, and the interface that I have created. Again, this is to maintain the traceability. For example, if I want to have, say, some headphone here, and I want to, it's already created, like between touch screen and tablet screen. All you have to do, same like in previous example, I just need to create the intersection. Typing in an X is going to create me a dependency between each of the requirements that is shown here and the components here. And moving on to spacecraft connector matrix. Here you're seeing the complete list of all the subcomponents that's available in the model and their different ports and their connection to other ports. For example, here avionics subsystem is interacting to the communication subsystem through the port, ground command, and TLM interface. So, and also it's very easy to use or view just information of certain subsystem by using data filters. So specifically useful when there is large amount of information and you need to check it. And again, this is the same information, but you are seeing it as tables. I can see avionics subsystem is interacting to communication subsystem with this port. And in another view, I'm going to show the information that's flowing between these two. For example, here, this is the information flow. the information that is being conveyed between the subsystem and the ports that are being used to convey this information. And this again, it's a matrix view. You can create DSMs from it. Again, it's a different visualization of the same information that you're seeing here. And this is kind of a consolidated view of just the GNC system, which is the guidance, navigation, and control subsystem. I'm showing the subsystem, the components of the subsystem here, all the components and their interfaces, each of those components, what are the behaviors that are assigned to those components, the different behaviors in total that's been allocated to the GNC system. Then what are the different parameters for each of these, and what kind of or what type of information flows through these activity parameter nodes. So these are activity parameters nodes. Again, these are behaviors are nothing but activities, and what type of information is flowing here. Let me show the final example. I'm just going to skim through it.
If anybody's got any questions on the ICD example, please put them in the Q&A. We have a quick question here from Sandy Friedenthal just about the FMEA profile. Is this one provided by No Magic, or did we do that ourselves?
Oh, no, we did that by ourselves.
Yeah.
So here I'm logged in. I'm selecting the project that I need to access. Okay, so this is specifically to view traceability relation between requirements, different elements in the model. I'm going to show refine, verify, and satisfy relation. So here there are different requirements for activity tracker. So I'm showing here a hierarchy of the list of requirements that's available. One useful view that you can generate from here, from all this information, and remove the monotonicity of the information you see. You have an option called create merge view. Once I do that, you can see easily the top level requirement, then there's sub level requirements. So for example, compatibility, you see specifically the requirements that are assigned to compatibility. And this is possible with any worksheets that you see in MapleMBSE. And this is to show or create a refined relation between use cases and the requirements. Say to create it's same as in other examples to the intersection between the use case and the requirement. By typing in an X, I'll be able to create the dependency. List of actors that's available in the model, different use cases that I can create. I can assign it to actors, add extended use case, included use case. And here, these are the requirements that's available, from which I could add different derived relation. I'm going to skip it, considering we don't have much time. And this is view of creating a dependency between the requirements and different test cases. And so it's kind of more of like a test plan. Something like this case for waterproof, I can add the description like it should be tested with 1 meter of 1 meter water. So I can add a procedure, and I can link this specifically to the requirement that has to be verified based on these test cases. Another useful way of seeing this is if you already have different test cases that are listed, you can bring all those test cases in and display them here. And you can map something from existing or from old model. You can easily bring them in, map to the new requirements that you have in your new model. For example, here I just created the test case and mapped it to test waterproof requirement. So similarly, if you already have existing test cases, you can map it to requirements or different elements that you want to actually link those test cases to. And this is just the block hierarchy of the activity tracker and their components. So this is a view to add properties to it. And this is a view to create different. This is a view to create the satisfied relation between the components and the requirements that we saw on the previous worksheet. So here, I just want to show some view as a reviewer, how they could use this view. So for this specific case, what I did is I have created a sample using MapleMBSE and Cameo systems modeler. Then I use Cameo system simulation toolkit to run simulation based on few instances. So here I'm displaying 3 instances for a turbofan. My interest here is to calculate pressure and temperature points at different levels. So these are the different points at which I'm interested to calculate the pressure and temperature. I'm showing just the view of the results of the instance. And I have added graphs which are based on the results that I get from the server model. So every time that there is some parameter that has been changed and we run the simulation again, or we update the parameters, you are going to get those results. And these graphs are going to be updated automatically because I have related them to the information that comes from the server. And here, this is view of a cost analysis based on the previous analysis, where I bring in the specific fuel consumption and relatively calculating the fuel consumption for other 2 instances that I showed in the previous. And here, this is something like a quote from a supplier. These are results from the preliminary analysis that you saw on the previous sheet. If I change something here, you will be able to see the graphs are updated automatically. It's again just as a review and to analyze some specific tasks. And the changes that I make here, once you save it, these are going to be saved back to the system model. So these are the views that specifically to users who are not going to contribute to the model, but just as a review. And that's all the example that I wanted to cover today. So if you have questions, please type it in. Currently, we have a question.
You go ahead.
Another question. So the question is if we could preserve the Excel formulas in the model, like in the parametric model, you cannot add Excel formulas to the model. So since they are just they are some kind of like on the layer of the Excel, we will not be able to save those Excel formulas to the server. But you can actually have interact with the parametric model, their actual formulas, and kind of use those in Excel, but it's not possible to store the Excel formulas back to the server.
Okay. Thanks,
I have another question from Stanford.
Okay.
The units in the Excel are from NoMagic QE DV SI library. So the units that I showed in the example, they are not taken from the QEDV library, but it's possible for us to also use the existing units from the profile. But for this specific example, I created the unit separately, but we can make use of any profile that's available in Magic Draw.
Okay, the next question from Sandy. When you create a branch, does this correspond to a branch on Teamwork Cloud? Is it a new copy of the model?
So when we create a branch, it's same as how we are creating a branch in Teamwork Cloud server. So it's not a new copy of the model. It's same as how branch works in the TWC server. Okay.
If you have any other questions, please type them in. I'm just going to wrap up and just talk about this sort of third topic, which is the evaluation. You know, how do we start? And you know, this is a big decision to implement MapleMBSE as anything that involves integration into any kind of engineering process. But you know, we are certainly here to help, and you know, we would like to see MapleMBSE being a core part of these processes. But we know that these are big journeys, and we have to start with this, you know, the first step. And for that first step, we are now introducing a free evaluation program. In the past, we didn't have this because there is actually certain costs involved on both sides in terms of implementing the actually even doing an evaluation. This is not something you can just install and then simply try it and expect to have a successful outcome. So there is a certain amount of guidance and how that is required for this. But certainly, under the current circumstances with COVID-19, that we feel that now is a good time to start putting some evaluations together and thinking about an evaluation project. And to help you with that, what we're offering is a free 2-month license to get up and started. We will provide you with training to make sure that you get your everything set up and working that the way that you want it to work, and also to talk about what you feel are the sort of success criteria for such an evaluation program, and then we will provide you with that support to achieve those goals during this 2-month period. This is, we're offering this now, and we're certainly very big, interested in hearing from you. And I'm hopefully, if you are interested in doing this, please contact us to arrange an evaluation project with us. You can email us directly at info@MapleMBSE.com, or you can go to our website, and there's a sign-up sheet there as well. Well, if you have any other questions beyond today or after today, please contact us at info@MapleMBSE.com. If you want to find out more information about the product, go to MapleMBSE.com. We have a dedicated website for this.